Hello viewers, welcome to my channel. I'm Hasham. In the last two videos, I have completed 6 problems on transportation. In this video, 7th problem I am going to do. In the last 6 problems, two problems I have done on IBFS. Finding out the IBFS through northwest corner rule. 2 problems. Then 2 problems on IBFS by least cost method. And 2 problems on Vogel's approximation method, VAM. Though the first stage in solving the transportation problem is finding out the IBFS, initial basic feasible solution. After finding IBFS, then we have to find out the optimum solution by applying optimality test. So in this video, complete problem on transportation. First, calculating the IBFS. Secondly, finding out the optimum solution. Both I am going to explain in detail. So, before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points which I have written, then I'll explain every point in detail. Come on, see the 7th problem. A wholesale distribution company has 3 warehouses from which supplies are drawn for 4 retail customers. The company deals in a single product, the supplies of which at each warehouse are as follows. So the origin is the warehouse and the destination is the customer. So 3 origins are there from goods are supplied. Warehouse 1, warehouse 2, warehouse 3. These are the supplies. So we take the warehouses in rows and customer number 1, 2, 3, 4 destination. These customers will take it in columns. So here supply are 20, 28, 17. So if you add up 20 plus 28 plus 17, it is 65. 65 is the total supply. And the requirement, demand at the 4 customers are 15 plus 19 plus 13 plus 18. If you add up the 4, you will get 65. That means problem is balanced. The total demand, total supply are equal. Conveniently, the total supply at the warehouses is equal to total demand from the customers. The table gives the transportation cost per unit shipped from each warehouse to each customer. The transportation table is given showing the transportation cost to carry 1 unit from warehouse 1 to customer 1, 3 rupees. From warehouse 1 to customer 2, 6 rupees. Warehouse 1 to customer 3, 8 rupees. Like this, all transportation costs are given per unit. Determine what supplies to dispatch from each of the warehouse to each customer so as to minimize overall transportation cost. So ultimately, in order to minimize the total transportation cost, how many units should be transported from each of the warehouse to each of the customer? How many units? That allocation we have to find out. So here in this problem, complete problem, first we need IBFS, then we need the optimum solution. So watch the video till the end. Because this is the first problem, complete problem I am going to explain. Don't skip in between, watch till the end. Now finding an IBFS by VAM. So first of all, warehouses are W1, W2, W3, 3 warehouses. And customers are C1, C2, C3, C4, 4 customers. Supply 20, 28, 17 given in the problem. Total 65. And demand at the customers are 15, 19, 13, 18. These are the units. Whereas these are the cost 3, 6, 7. These are the cost incurred to transport 1 unit from each of the warehouse to each of the customers. The costs are written at the upper right corner so that the remaining space is available for making the allocations. We are following VAM method. In Vogel's approximation method, we need penalties. Penalty means the difference between the smallest cost and the next smallest cost in each row and each column. Already in the last video, 2 problems I have explained regarding the IBFS by VAM. Same thing. So here up to here the table is given in the problem. These are the row penalties and these are the column penalties we have drawn, right? I have drawn only 1, 2, 3. 3 penalties. Better you make 4, 5 penalties also. We don't know our solution we can get in 3 penalty or 4 penalty or 5 penalty, right? So first of all, row. First row, 3, 6, 8, 5. What is the smallest cost? 3. What is the next smallest cost? After this 3, what is the next smallest cost? 5. The difference 5 minus 3 is 2. The penalty is 2. Here the lowest cost 6, 1, 2, 5. Lowest cost is 1. Next lowest is 2. The 2 minus 1 is 1. Next here third row minimum is 3. Next minimum is 7. So 7 minus 3 is 4. Row penalty completed. Now column penalty. 3, 6, 7. Lowest is 3. And the next minimum is 6. So 6 minus 3 is 3. Right? Here 6, 1, 8. Lowest is 1. And the next lowest is 6. So 6 minus 1, 5. Right? Here the lowest cost is 2. Next minimum is 3. So 3 minus 2, 1. The lowest cost is 5. Next minimum is 5. So 5 minus 5 is 0. That's all. So we have calculated first penalty for row and column. Find out which is the highest penalty, largest penalty. Sometimes we get the largest penalty in rows, sometimes we may get in columns. Here 2, 1, 4, 0, 1, 5, 3. So we can see 5 is the highest penalty. So round off the 5. In which column we are getting this 5? In the column C2. In this column C2, what is the minimum cost you select? Minimum cost is 1. In this one cell, we have to make the allocations depending on the row total and column total. Here row total is 28, column total is 19. So 28 or 19, whichever is less, 19 is less. So I am allocating 19 in this cell. So 19 minus 19, 0. 28 minus 19, so 28 minus 19 we are getting 9. So here 9 remains 9. So here column is blocked, column is exhausted, 0. So block the column. Here I am blocking the column like this. Block the column. Or first penalty completed. Now I am coming to the second penalty. Penalty 2. What is the lowest cost in the first row? 3. Next lowest, 5. So 5 minus 3, 2. We should not consider the blocked or allocated cells. Only blank cells we must consider. Second row, 6, 2, 5. Minimum is 2. Next minimum is 5. 5 minus 2, 3. Here minimum is 3. Next minimum 7. So 7 minus 3, 4. Column wise, 3 to 6. Minimum is 3. Next minimum is 6. 6 minus 3 is 3. Here it is exhausted, put a dash. Then 2 to 3, 1. Here 5 minus 5, 0. Second penalty completed. Find out what is the highest penalty here. 2, 3, 4, 0, 1, 3. The highest is 4. So round off the 4. In which row we are getting this 4? Row W3. In this column, what is the lowest cost? 7, 3, 9. Lowest cost is 3. So now we are allocating in this 3 cell. Row total 17, column total 13. Whichever is less. 13 is less. So I am allocating 13 here. 13 minus 13, 0. 17 minus 13 is 4. The column has become 0. To block the column. This column I am blocking. That's all. 2 penalties completed. Now third penalty. What is the minimum cost in the first row? 3. Next minimum 5. So 5 minus 3, 2. Here minimum is 5. Next minimum is 6. So 6 minus 5, 1. Here minimum is 7. Next minimum 9. So 9 minus 7, 2. Row penalty completed. Now column penalty. 3, 6, 7. Minimum is 3. Next minimum is 6. 6 minus 3. 3. This column is exhausted, dash. This column exhausted, dash. 5, next 5. So 5 minus 5, 0. Now find out the highest penalty. 2, 1, 2. 0, dash, dash, 3. 3 is the highest penalty. So round off that 3. This 3 I have rounded off. In which column we are getting? First column. What is the minimum cost in the first column? 3 is the minimum cost. To fill up that 3 cell. Here row total is 20, column total is 15, whichever is less. 15 is less. So I am allocating 15 here. So 15 minus 15, 0. 20 minus 15, 5. Column has become 0. So block the column. This column I am blocking. That's all. Now we don't require any other penalty, because if in any row or column only one cell is left, we will take the balance. In the first row, you can see only one cell is there. Unoccupied one cell. What is the row total here? 5. So this row total 5, I will allocate here. So if I allocate 5 here, so 5 minus 5, 0. 18 minus 5 is 13. Right? Then second row, again one cell is unoccupied. What is the row total here? 9. So I will allocate 9 here. So 9 minus 9, 0. 13 minus 9 remains 4. Only one unoccupied cell is left. Row total 4, column total 4. So here I have taken 4. So 4 minus 4, 0. Here 4 minus 4, 0. We have made all allocations. Now you confirm zeros are there in the supply or not? 0, 0, 0. All supplies are 0. Here 0, 0, 0, 0. All demand, customers' demand is also 0. Completed. IBFS completed. The number of allocations. How many allocations are there? 1, 2, 3, 4, 5, 6. 6 allocations are there. M plus N minus 1. N stands for number of rows. How many rows? 1, 2, 3. 3 rows. N stands for number of columns. How many columns? 1, 2, 3, 4. 4 columns. Minus 1. 3 plus 4, 7. 7 minus 1, 6. So what is happening? Number of allocations are equal to M plus N minus 1. Number of allocations are 6. M plus N minus 1 is also 6. So if this happens, then the problem is called non-degenerate problem. That means before going for optimality test, we have to confirm that number of allocations must be equal to M plus N minus 1. Then only we can proceed ahead. So two conditions are there. The first condition, number of allocations must be equal to M plus N minus 1. And second condition, all the allocations are independent. Independent means no loop should be formed in a pair of cells. So here every cell is independent. There is no square or there is no rectangle formed at 4 corners. That means all the cells are independent. The problem is non-degenerate, and we can proceed to apply for optimality test. So here I have given, since the number of allocations are equal to M plus N minus 1 and the allocations are independent, the problem is non-degenerate. Now we proceed to find out the optimum solution. Up to here already we have done in the previous problem. From this part, this is completely new, because first time we are going to find out optimum solution. So how to find out optimum solution? Same table. See here, same table I have drawn. I have not taken the cost here. First of all, I will take the cost 367. 367. Second 618. 618. Then we have 823. 823. Next we have 559. 559. We have taken all the cost. Now take the allocations also. The first allocation is 15 in the first cell. The first cell I am taking 15 here, right? The second location is 5 in C4. Here I have taken 5. Next is 19 in C2W2. C2W2, 19. Then 9. Here I have taken 9. Then here 13. This 13. Then next one is 4. The same allocations what we got in IBFS, the same allocations I have taken. The same table I have prepared, no penalties. Penalties are over. Here, 2 extra, 1 column, 1 row extra we have to make. This supply, up to supply and demand is same. The new row and new column is VJ. A new row is opened VJ, V1, V2, V3, V4. Because 4 columns are there. Every column V1, V2, V3, V4. Similarly here UI. So U1, U2, U3. 3 rows are there. So we have taken U1, U2, U3 and V1, V2, V3, V4. We are following Modi method to find out the optimum solution. In Modi method, we have to find out the opportunity cost in each of the unoccupied cell. These are the unoccupied cells. In these unoccupied cells, we calculate opportunity cost. If all the opportunity costs are positive, we have reached the optimum solution. If any one of the opportunity cost is negative, then it is not an optimum solution. We have to make one more table, one more iteration, then only we can be able to get the solution. That is the optimality test. So how to find out the opportunity cost? Now I am explaining. First time I am explaining, so give more concentration here. To test the optimality, we find the opportunity cost. What do you mean by opportunity cost? The cost incurred by occupying the unoccupied cell. What is the cost incurred by occupying that unoccupied cell? Right? That is called opportunity cost. By calculating the values of UI and VJ for each of the occupied cells. This UI and VJ, U1, U2, U3, V1, V2, V3, V4. By calculating this UI, VJ, we can be able to find out opportunity cost. Right? Maintain a notebook, pen, calculator ready. Whenever I am saying something, immediately you write it down. Then only you can be able to remember the next problem easily you can follow. Now, we can find the other values. First of all, we arbitrarily assign U1 is equal to 0. So, any one of the U value we can take it as 0. U value or V value. Any one. So, arbitrarily I am taking U1 is equal to 0. Here, U1 is 0. We can find the other values of UI and VJ by the following equation. Now, arbitrarily we have taken U1 0. Anyone you can take U2 0, you can take U3 0, anything you can take. But I am taking U1 is equal to 0. Then the other values of UI and VJ can be found by using this equation. Cij is equal to UI plus VJ for occupied cells. For every occupied cell, we apply this equation. Cij is equal to UI plus Vj. Cij stands for cost of ith row and jth column. I is the row and j is the column. C is the cost. For example, this is the occupied cell. The first one is the occupied cell. This cost 3 rupees is the Cij. So here, what is the location of this cell? First unoccupied cell location, first row, first column. It is the first row, first column. So I will write down C11. C11 is equal to U1 plus V1. How much is C11 here? 3. This 3 is the C11. So C11 is 3 is equal to U1 plus V1. How much is U1 we have supposed? 0. So 3 is equal to 0 plus V1. 0 plus V1. So 3 is equal to 0 plus V1 or V1 is equal to 3. We got one value. We got one value. V1 is equal to 3. So I am writing down 3 here. That's all. One value we got. Now second occupied cell is this one. This is the occupied cell. So what is the location of this cell? First row, fourth column. First row, fourth column, C14. So C14 is equal to U1 plus V4. C14 is equal to U1 plus V4. How much is C14? 5 rupees. The cost, 5 rupees. So 5 is equal to U1. How much is U1 there? 0. Plus V4. Or, so 5 is equal to 0 plus V4. Or V4 is equal to 5. Two values we got. V4 is equal to 5. Right? Now we can make use this cell. This occupied cell we can make use to find out the value of U2. Because V4 we are having. We have V4 and we can calculate U2. What is the location of this cell? Second row, fourth column. Second row, fourth column, C24. So here C24, U2 plus V4. C24 is equal to U2 plus V4. How much is C24? 5 rupees. So 5 is equal to U2. U2 we don't have. We don't have U2. U2 plus V4. Already V4 we got it 5. 5. So this 5. Take this 5 to RHS or bring that 5 to LHS. So 5 minus 5. This 5 I am taking it, bringing it to LHS. So 5 minus 5 is equal to U2. Or U2 is equal to 0. Simply changing the side. 5 is equal to U2 plus 5. Bring the 5 to LHS. This plus 5 will become minus 5. So 5 minus 5 0. So U2 is equal to 0. We got value U2 is equal to 0. Now we will make use this occupied cell to find out V2. This occupied cell will make use to find out V2. What is the location of this cell? Second row, second column, C22. So C22 is equal to U2 plus V2. How much is C22 here? 1. So C22 is 1 is equal to U2. How much is U2 value? 0 we got it. Plus U2 is 0 plus V2. So what it will become? 1 is equal to 0 plus V2. Or simply we can write V2 is equal to 1. We got V2 is equal to 1. Right? Now we got this value. Now we'll make use this cell. Because already we have V4. We can find out U3 if we take this cell. We cannot make use this cell because we don't have V3. We don't have U3. At least one should be there. So here we can make use this cell. 3, 4. Third row, fourth column. C34. C34 is equal to U3 plus V4. Right? How much is C34? 9. So 9 is equal to U3. U3 we don't have. Plus V4. V4 we have 5. Now bring this 5 to LHS. So 9 minus 5 is equal to U3. Then U3 is equal to 9 minus 5 is 4. We got value U3 is equal to 4. So U3 we got 4 value. Finally, we make use this occupied cell to find out the value of V3. Right? So what is the location of this cell? 3, 3. Third row, third column. So C33 is equal to U3 plus V3. How much is C33? 3 rupees. So 3 is equal to U3. U3 already we got it 4 rupees. Plus V3. We don't have V3. V3 we don't have. Now bring that 4 to LHS. So 3 minus 4 is equal to V3. 3 minus 4 is equal to V3. So 3 minus 4 minus 1. So V3 is equal to minus 1. V3 is equal to minus 1. That's all. So here V3 is minus 1. So I have calculated all U1, U2, U3, V1, V2, V3, V4. All the values we have calculated. Now we need the opportunity cost. What is the formula for opportunity cost? See here carefully. The opportunity cost of each of the unoccupied cell are determined by the following relation. So we have to calculate the opportunity cost of each of these unoccupied cells. So how to find out? Equation is given. Delta Ij is equal to Cij minus Ui plus Vj. Delta Ij is the opportunity cost. This delta Ij means the opportunity cost. How to find out opportunity cost? Subtract Ui plus Vj from Cij. Cij are these values. This 6, 7, 6, 8. The actual cost is the Cij. Cij, from Cij, deduct Ui plus Vj, right? For example, this unoccupied cell. What is the location of this unoccupied cell? 1, 2. That means first row, second column. So delta 1, 2. Here you can see delta 1, 2 is equal to C12. How much is C12 here? 6. C12 is 6, this one. So 6 minus U1 plus V2. U1 plus V2. How much is U1? 0. How much is V2? 1. 0 plus 1. So 0 plus 1 is 1. So 6 minus 1, 5. That's all. Or simply, without writing this, directly we can calculate here also. This is the actual cost. From actual cost, subtract the sum of Ui plus Vj. How much is Ui? 0. How much is Vj? 1. So 0 plus 1 is 1. So 6 minus 1 is 5. So write 5 on the left side bottom corner. The right side cost is the actual cost. And this left side cost is the opportunity cost. We got it by this equation. So we have calculated one opportunity cost. Now this opportunity cost. What is the location here? First row, third column. Delta 1, 3. So here you can see delta 1, 3 is equal to C13 minus U1 plus V3. How much is C13 here? 8. So I am taking 8 here. Minus U1. U1 is 0. V3. How much is V3? Minus 1. So plus into minus, minus 1. So 0 minus into minus 1. So minus into minus will become plus. So 8 plus 1. It will become 9. So here I am taking opportunity cost 9. In other words, you can say like this also. 8 is the actual cost. Now 8 minus Ui plus Vj. Ui is 0, Vj is minus 1. So 0 minus 1 is minus 1. So 8 minus minus 1. So minus into minus will become plus. So 8 plus 1, 9. That's it. Right? This one over. Now this unoccupied cell. What is the location? Second row, first column. 2, 1. Delta 2, 1. Delta 2, 1 is equal to C21 minus U2 plus V1. How much is C21 here? 6. 6 minus U2. U2 is 0. Plus V1. V1 is 3. So 0 plus 3. 3. So 6 minus 3 is 3. So opportunity cost is 3. We got 3 here. Right? Or in other words, if you don't want to make all these calculations directly in the table itself, you can calculate this value. So our actual cost is 6. From 6, deduct the sum of U2 plus V3. Because here U2 is 0 and V1 is 3. So 0 plus 3 is 3. So 6 minus 3 is 3. Now come to this cell. Second row, third column, 2, 3. So delta 2, 3 is equal to C23 minus. So delta 2, 3 is C23 minus U2 plus V3. C23 is 2. So 2 minus U2. U2 is 0. And V3 is minus 1. So 0 minus 1 is minus 1. 2 minus minus 1. So minus into minus will become plus. So it will become 2 plus 1. 2 plus 1 is 3. So we got 3 here. Now this unoccupied cell. What is the location? Third row, first column. Delta 31. Delta 31 is equal to C31 minus U3 plus V1. Minus U3 plus V1. How much is C31 here? 7. So C31 I am taking 7 minus U3 is 4 plus V1 is 3 is equal to 4 plus 3 is 7. So 7 minus 7 you will get 0. Here 0. Right? Or in other words you can see like this. Actual cost 7. From 7 subtract the sum of UI and VJ. UI how much? 4. VJ is how much? 3. So 4 plus 3, 7. So 7 minus 7, 0. Last one. This is an unoccupied cell. Location is second row, second column. Delta 2, Delta 3, third row, second column. Delta 3, is equal to C32 minus U3 plus V2. How much is C32 here? 8. So 8 minus, then U3 is 4 plus V2 is 1. So 4 plus 1, 5. So 8 minus 5 is 3. That's all. This one 3. Over. All the opportunity cost we have calculated. See here, opportunity cost are 593,303. Here also you can see 5,9,3,303. For unoccupied cells we have calculated opportunity cost. If all the opportunity costs are 0 or positive, then we reach the optimum solution. If any one of the opportunity costs are negative, then it is not optimum. One more table we have to make. But fortunately, in this problem, we got the optimum solution. According to the optimality test, the current solution is optimum solution since all the opportunity costs are 0 or positive. No opportunity cost is negative. We don't have any negative opportunity cost. So we got the optimum solution. Now what are the allocations here? W1 to C1. First assignment, W1 to C1. How many units? 15 units, 3 rupees. 15 units, 3 rupees. Second, W1 to C4. W1 to C4. How many units? 5 units, 5 rupees. 5 units, 5 rupees. W2 to C2. W2 to C2. 19 units, 1 rupee. 19 units, 1 rupee. Then W2 to C4. W2 to C4. How many units? 9 units, 5 rupees. 9 units, 5 rupees. Then W3 to C3. W3 to C3. How many units? 13 units, 3 rupees. 13 units, 3 rupees. Last one, W3 to C4. W3 to C4. 4 units, 9 rupees. 4 units, 9 rupees. That's all. How many allocations? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 allocations we have taken. Now 15 threes. 15 into 3, 45. 5, 5, 25. 19 into 1, 19. Then 9 5s, 45. Then 13 into 3, 39. Then 4, 9, 36. 9 4s, 36. That's all. Now take the total. 45 plus 25 plus 19 plus 45 plus 39 plus 36. It comes to 209. 209. That's it. Finished. Problem finished. That means these are the optimum allocations. And by following these optimum allocations, our total transportation cost is minimum 209. If we follow any other allocation other than this, then definitely the total cost will be more than 209. Minimum cost is 209 for this allocation. That's it. So this is the first complete problem I have explained you regarding the IBFS, then optimum solution. First attempt itself you may not be able to understand. So watch the video twice. Maintain the notes. Write down all the points what I'm explaining. Practice. This operation research subject requires a lot of practice. Only listening, watching will not suffice. You have to make the practice. Take the problems, already problems you have taken the printout, and do it yourself after watching this video. If you are stuck at any point, again rewind back. Come back to the video and see where you are committing the mistake. In this way you can be able to learn. So totally 7 problems I have completed. Inshallah we'll start the next 8th problem in the next video. So if you are satisfied, give a like to the video, share my channel, give your comments, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah we'll continue the next problem in the next video.